Hey, and welcome everybody. My name is Michael. I'm running Food Cafe together with Sophia. Sophia's taking care of the live stream tonight. So give Sophia a big hand. I'm so happy to see you all here tonight and you on the internet as well. This will be awesome. And before we start, I would like you to ask you, is there anyone here who do not want pizza in the break? So, okay, cool. Do we have any vegans around? One. Two. Do we have any gluten intolerant persons? Okay, perfect. So, yeah. Tonight we have a sponsor, Capiche. Anders, would you like to say some words about what is Capiche?
What is Capiche? Capiche is a software, and thank you. We help companies with lots of scientific data to make it more accessible for a wider range of users. Scientific data to be explored and not just managed by data scientists, because most data isn't that. It's very expensive to gather, but it's not used very well. Anyhow, we sponsor Food Cafe because we want to have a live event, a forum for you developer, and we want it lively. So it's very nice to see that Johan and his subject has attracted so many people. Warm welcome. Over to Johan.
Thank you.
Before, I would like to say some words about Johan. Sorry, I just love to be on live. Johan is a good friend of mine. We've known each other for ages. That's why we look so old together, especially me then. Right. Anyway, since I started Food Cafe 2012, I think Johan has been at Food Cafe every year.
Except last year.
Except last year, yeah. It was...
Pandemic and stuff.
Pandemic, yeah. I can't remember that shit anymore. So I'm really happy that Johan is back again. I think you should give him a big applause. Thank you, Johan, for coming back and show us.
Thank you. I'm also really happy to be here. There are a lot of faces that I haven't seen for quite a while, and it's really nice to see everyone. But today we're going to talk about event sourcing with functions, and we are going to talk about pure functions as well, but many different kinds of functions. And the agenda, I will have two different parts. So the first part, we're going to talk about event sourcing, subscriptions. We're going to talk about or look at a domain model and how we can model that with just functions. And then in part two, we will continue looking at this example, but now we will actually see how we can store these events that we will get from the our example domain model that we're going to look at. And when we do that, we're going to look at this open source library that I've created for the JVM, mainly Java and Kotlin, called Occurrent. And we're going to talk about something called CloudEvents that I've decided to use for this library. So the goal of the talk, is to show what event sourcing is, if you're not familiar with event sourcing. I will do a little introduction. Hopefully you will get the gist of it if you don't know what it is, but hopefully you have some idea already. Another thing that I want to do is to explore if adoption of event sourcing can be made easier, because often when I read blog posts about event sourcing and CQRS, etc., to me they sound quite complex, and I can imagine that it looks quite scary if you haven't seen these things before. And I don't think it necessarily has to be this complex. So my goal is to keep the complexity down, but I don't know, maybe some of the things here will look a bit complex if you're not used to them. But when I say complex, I mean that the things that I will hopefully present here are simple in the rich hickey sense of the word, like they're not intertwined with each other. So like you bring concepts apart. And I think that if you model your domain model with just functions, you don't necessarily need all the advanced things that some frameworks provide. And that doesn't mean that these frameworks are bad or that it's a bad choice to choose them. That's definitely not what I'm saying. I wanted to explore if I could, me as a, I have 2 kids, and I just went up earlier for a couple of months and started hacking around. Can I do something that works? And I think that I'm kind of proud, but you can see, and it's work in progress, and it's open source. And yeah, I will tell you more about that in part 2. So stick around. So what is event sourcing? Well, every information system needs to store data somehow, right? And typically this is done by, we have a database, like a relational database. We create a table, and when something changes in this table, we just replace the value, and we lose the changes. So event sourcing is instead that we focus on these changes, and we don't necessarily store the actual snapshot. We store the changes instead. And these changes, these are what we call events. And events are immutable pieces of data that shouldn't change in most circumstances. And from these changes, you derive the current state instead of just having the current state. So an example of this, you can imagine that this is a table. Can I have a mouse pointer somewhere? Maybe I don't need it. This is a table, and here are some stuff. This is like I'm working at Parkster, a company called Parkster. When we work, we have this app for starting and stopping your parking and paying your parking fees and so on. So you can imagine that we have this parking table. We have an ID of the parking, some driver, some start date of the parking. I just made this up, but we probably have something like this. And then you can imagine that maybe you extend the timeout of the parking on something, and then we just update the end date or something like that on this table. But we lose the actual history. So what this actually is, what this table actually is, this is a snapshot or a projection of the current state of the system. But what we've lost here is actually how we have, got to this particular state, right? So maybe this is what happened. Maybe some long-term ticket was purchased, and then the parking was started. Then the parking was extended, and blah, 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 blah. A lot of things. And this, from these kind of things here, from these facts, we can just derive the current state. And this is what we do in event sourcing. So we focus on this part here, and we say that this is really important because you can get from here to here, but not necessarily the other way around. And you can imagine that this can be really quite useful in many cases. Yes, I mean, one example is if a customer, calls customer support and wants to have support, why am I in this state? I've done nothing wrong. And then the customer service can say that, yeah, you've done something wrong. And that's good. And I mean, you can use this for all kinds of things. For example, I mean, if you get tired of all your tables, you can move to, I don't know, something else, MongoDB or something. Neo4j, maybe that was a better fit for your projections somehow. And you can have multiple of these, and we will talk more about that later. But we are going to zoom in a little bit about these events, because when I say events here, what do I mean? I mean, there are many different kinds of events. And so what I mean here, these events that we saw before, these are so-called domain events. These are something that can be meaningful to the business. So in the best world, then the business people should also understand what this event means. Like, what does it mean when a long-term ticket is purchased? Hopefully, other people than just developers understands this, so that we can talk about them together. Yeah. And as I mentioned before, this is also very important. This is a fact. You should, most of the time, not change an existing event. Instead, you append something new. Like it's the same thing in the real world. I mean, things happen all the time, right? And it's hard to change the past. I don't know how to do it, at least. You append new stuff. Maybe there is a way, I think, with some things in relativity or something. Maybe you can get around it theoretically. But we can leave that to the break, maybe. But yeah, this means that events are always expressed in the past tense. So it's always long-term ticket purchased. It's not purchase long-term tickets. That's something else. That's something that you want to do. So events shouldn't change most of the time. And yeah, you get auditing for free. No, I changed slide. I didn't notice that. Sorry about that. I was really surprised. Okay, so why should we be using this event sourcing? And this is what I hear on the word on the street. You know, it's like what do people usually say? Why should we use event sourcing? Well, we can use it for high scalability because this is not really event sourcing per se, but maybe it's more like CQRS. We will talk more about that later, so never mind if you don't understand what it is. But it's a thing that we can separate reads from writes. So we can, for example, if we don't have as many writes as reads, we can scale the reads independently, and then we can really scale them and have a highly scalable system. And people also say that it's well suited for complex business domains, which, well, that's also true. It can be simpler, again, in this rich hickey sense, since you separate read from write, so you can focus on your write model independently of your read models, which can be quite nice. You can replay the history. That's always cool. You can investigate errors, like why do we have bugs in production? What actually happened? And yeah, you get auditing for free. And this is, I mean, yeah, it's. I in some sense I agree with this, but I don't think that this is the most important thing in my mind, because this is what I think is more important. I think that it's natural for us to talk about events. It's something like humans are evolved to tell stories, and yeah, stories, they consist of events, right? So it gets kind of natural, and by talking about events and, you know, getting them, how do you say it? We make them a first-class citizen in some sense. Then we have a way to discuss with the business that is non-technical. I mean, before I started thinking about events, when I, you know, started thinking about problems, then, you know, you draw some relational table and, oh, you did some mappings here and there and blah, blah, blah. But you don't, I mean, now I find it much more easier to just think about, okay, this thing happened, what happens after that? You know, you bring out a little story around that. So I think that is something that is really nice. This ties in with what I said in the previous slide, like better separation between logic, because if you're thinking about this, like this thing happened, then this thing happened, and blah 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 blah, then you can imagine that, okay, this becomes like a kind of natural boundary between these two things, instead of coupling everything together in a large mega transaction and all your code is tied together. Then it becomes a bit more natural to separate things and to have smaller pieces of code. And this is, I think there's something to this, but I'm not sure because I haven't tried it that much. That's why I have an asterisk here. But there's something called event modeling that is very interesting. So you can model how your system works, essentially. And I can imagine this, that if you have been doing this for a while and you get used to it, then I think that can actually help with time estimates. At least that's what Adam and you something that is the founder of event modeling. He really claims that, and I really think that there is something to that as well. So I think that's really interesting. And then also easier to extend during long periods of time, also because of this lower coupling, that maybe you don't have all your code in a big transaction, things that don't really need to belong together. Here it's better it's more easily to separate things. Okay. So how can we structure the right side of our application? Normally, I mean, how do we do that? And I think this is one approach that I think is a good one. So here you can imagine that you have some API and you have something called an application service. An application service, this is just a fancy name for something that reads from the database and then calls your domain model and takes whatever the domain model returns and puts it back into the database. So imagine that you have REST API or something, HTTP API, GraphQL, whatever, and you send something to this API, like a command or a request, if you like. A command, this is also a term in event sourcing. This is something that you want to do, an intent, and this is very different from an event, right? Remember, the event is a fact. Something has happened. The command, you don't know if you want this to happen, but maybe you're not allowed to do the thing you want to do. For example, maybe you want to park in a garage or something that is closed. Then it's not possible. We will deny the parking. But that's the intent that you want to do, and this is for a particular entity. For example, a particular parking zone. I want to park in at this particular parking zone. So what happens is that this command is somehow routed to this application service. So what do? Yeah, now we read our current state of this parking zone. We read our table from the database. We map it using Hibernate or something, and we get some state back. And then what can we do? Now that we have this state, then we want to apply some behavior to it, right? So then we can just take this state and our intent, our command, we pass these two things to our domain logic, and what it can do is to update the state if all invariants are fulfilled, and it will return an updated state that we will store in our database. And I think this is a nice approach, and this is not using event sourcing, but let's see. How can we make this event sourced instead? Oh yeah, yes. Look at this first. Now we can see. Oh, can you see? The only thing we changed is this. From an relational database to an event store. But let's see if there's something else. Okay, the command comes in again. Goes to the application service again. Okay, now we read events, but it's still the same thing, right? This is the state. We read the state. Now the state just happens to be some list or sequence of events instead of a hash map, essentially. So it's really the same. And what do we do then? Okay, we pass this to the domain model instead. What does it do? Oh, it returns new events. And look, we just store them. So it's the same thing. There's no difference, right? It's event sourcing is just a list instead of a map. That's what event sourcing is. Thank you. Okay, but you probably want to do more things, right? And just save this list of events. So then we come to the other side, like side effects and queries, etc. So maybe you want to send an email to some user that has just registered, or maybe you want to block a user from logging in for a period of time if he or she has misbehaved, or create some materialized view with maybe some 10 latest parking or 10 latest games played or something. And this is where subscriptions come in, and they kick in here after we have stored our events in the event store. And this is really important. It needs to be, it needs to be after they have been stored, so that we know that these things are actually durable stored in the storage. Then we can create a subscription that subscribes to new events as they come in. And we can subscribe, for example, on game 1 event or something like that. And if the game is won, then maybe we send an email to some email provider to the winner of the game. What else can we do? Well, with the subscription, again, you subscribe to events, and you can use that to create this view. For example, the top or the 10 latest games won or something. And this is what enables CQRS, actually, because the only thing we've done here, we've taken some events and now we've written them as a hash map somewhere. And CQRS. And then we can use this materialized view, like if this person goes into a website, nice website here, maybe this little thing here is the top list or the 10 latest games or whatever it is. So then it just calls an API, another API probably than the one that we saw before. And it just loads the data from this pre-populated view. So we have a different, different way of accessing reads from writes, and that is essentially CQRS. And we enable that with subscriptions. Pretty cool. We can use subscriptions to a lot of things. What else can we use subscriptions for? Well, we can use them for integration. So here we get the events, and we can send events to some broker, and then they can be forwarded to another service. And we can also use subscriptions to enable integration. Yeah. But now I just want to mention something here, because this is worth zooming into. That the events that if you want to do integration, you should probably think a little bit, because you shouldn't just send your events that you store in your event store just outside to everything. Instead, what you should do is to transform your events typically to something called integration events. And if integration events are larger, so instead of just sending very small piece of information all the time so that the consumers need to build their own snapshots, instead you send a larger event with more information. And this becomes a part of your contract to the outside. If you're familiar with domain-driven design, this will be a part of your published language. But internally, you don't. So you can keep your domain events local to your bounded context, if that makes any sense. But that can be quite important, actually. That also means that you can change your events internally however you like, without affecting the outside world necessarily. So that's it, right? I mean, event store. You just need this event store, something that stores a list instead of a hash map, and then you have subscriptions. And then you need this domain model maybe, and some API probably if you want someone to call your stuff, and then some infrastructure things like this application service. There is only a couple of lines of code, and I will show you that in part 2 if you stick around. We'll see. But let's see how we can actually implement a domain model here. And I just want to emphasize something here that I want to show you here, how we can create this domain model without any dependencies whatsoever. What I mean no frameworks or libraries. So when you look at this code, you will find nothing of that sort. And that is just me. I want to show you that that's possible, and that you can use my library to use this later. So you can design it however you like. But of course, I mean, if you need a library, you should probably use it, right? But this is an example. I also want to emphasize here that we will look at a bit more functional code here, but it doesn't have to be functional as long as you adhere to the contract that I will show you soon. It can be imperative as well, and that's fine. So don't be too hard on yourself if you don't understand everything. But we're going to look at this game. It's called Rock, Paper, Scissors. Hopefully you are somewhat familiar with it. You play rock or paper or scissors, and then someone wins. We're going to go beyond the very basics of rock, paper, scissors. So we're going to look at a multi-round game of rock, paper, scissors. And we're not going to look at all aspects of the game here. You can find my code is here somewhere on GitHub if you want to look into it. And we're going to focus on the right side, like the actual game. And we will, the example here will be in Kotlin, but it's not really the language that matters all that much. It's mainly the principles. You can even write this in Java reasonably well nowadays, believe it or not. But we're going to look at Kotlin. And again, if you don't understand Kotlin, hopefully you will understand something, but it's not the end of the world. It's the takeaway is the principles. Okay, but let's first look at the events. And this is, I've just made this up. And there are in no particular order here. We have first player join game, second player join game, game created, game started, and the rest. And I have decided here in this example to differentiate between game created and game started. And there's a reason for that I will show you in part 2. So stick around. But yeah, imagine that you can you can create a game in advance, and then 2 players can join. That's why I've separated these two. Maybe I don't know. I can create a bonus game in advance. You win 500 something if you played this particular game. I don't know, but yeah, this is just me thinking of these events. Okay, so how can we represent this in code? So this is Kotlin Code. Hopefully it's you can kind of understand it. We have an interface called game event that all my data classes here implement, and it just contains because every event here needs the ID of the game and some timestamp. So I have forced everyone here forced all the data classes here to implement it. And a data class in Kotlin, this is essentially just a hash map with some types, a record maybe in other languages, or a class in Java, but in Java it would be 200 lines of code probably, before Java 16 at least, or 17, I don't remember. Yeah, and this is pretty cool. If you're not used to Kotlin, I mean, you can have this sealed hierarchy of things. So if you declare this as sealed, when you do like a when, like in a switch in Java, if you switch over an instance of an event, you're forced to handle all cases per compiler. And that's pretty nice, because if you add a new event later, you're forced to handle that case everywhere. Otherwise, you will get a compiler error. And that is quite nice. This is why I've used sealed here. Oh yeah, and what I want to point out here is that I've modeled this exactly as I wanted to. You cannot, if you're used to Java or Kotlin or something like that, maybe you notice that I have no Jackson annotations. There are no default constructors or anything. This is just vanilla Kotlin with no libraries for serialization, etc. Nothing that there's no @aggregate ID or something. Nothing. Interesting, right? And then we have commands, and yeah, I only have 2 commands here. We have create game and then play hand. Those are the only 2 that exists. And again, I have used this some sealed interface here. And then we have this, the function. We have only, in this example, we will look at different examples later, but here I just have one function that takes a sequence of events, and a sequence is just a lazy list, essentially, in Kotlin. So if you're used to Java, this is virtually the same thing as a stream in Java. So it's just that it can be lazy. And then we take the command as a second parameter. And this is the contract. As long as your function takes a list or sequence or something of events and a command, and return a new or a list of new events, new changes, or no changes at all if it's an idempotent operation, then you can write your function however you like. But we're going to zoom in this example and look at how I've implemented this, using a little bit more functional approach. But it's deliberate here. I don't want to go too functional, so I don't want to bring in, we will talk a little bit about that later, but I won't bring in functors and stuff. So I hope, my goal is with everything with this Occurrent library as well, I want to be pragmatic, that you should decide yourself what you want to do. So here I don't want to go too much in one extreme or the other. I want to find some middle ground. So yeah, and here is an example of that. Maybe you can see here already that this function is not really pure, or at least it's not total, because we're throwing exceptions. And this is something that we're really used to in Java and Kotlin as well. We do this all the time, for better or worse. But I will show you an example later how we can refactor this if we want to. But the first thing that we do when we in this function here, when we get our events, is that we call a function called evolve. And this is the function that takes our events and build up our current state. So what is our state of this game currently? And we will zoom in and see how this looks. But first I want to explain this function. I hope everyone is familiar with this, because this is an awesome function that you can use. You virtually only need this function, then you can implement most stuff. But just to get everyone on track, so imagine that we have a list with elements 2, 4, and 3, and we have a function that just adds two elements together, like a sum. Then we can call a fold function that is a function that exists on a list or sequence in this case. So we call fold, and then fold also takes a start value. So if we call fold with a start value of 0, and then we pass it this higher order function, a plus b, what will happen is that the first iteration we will have 0, a will be 0, and then b will be 2. And the result will be 2. In the next iteration, a will be 2, b will be 4, sum will be 6. It's fed back into this thing, and then we have 6 there and 3, and the result will be 9. And it looks like this. Yeah. Yeah, but that's essentially how a fold, or how you use a fold. But you can, as I said, this, yeah, you can use fold to evolve or rehydrate. This is also sometimes called rehydrate, a rehydration function you get from your events to some model. But you could use a for loop here as well, if you really want to. But I don't want to do that here, at least. So and again, some Kotlin things. This is you can see here that I have. This is called an extension function. You probably know what this is. A lot of languages has that nowadays. So this is not a function that exists on this sequence. I've just added it to the sequence, so I can call evolve. And also worth noting maybe is, yeah, I call evolve here without any parameters. But if you see here on the definition here, I can actually provide my current state if I want to, but I have a default. By default, it's null, so I don't have to specify anything here. But I'll show you later in just a slide or two how I'll use that. Then I just call this fold method. But now instead of having 0 as the current state, I take the input here as the first parameter. So now it will actually be null in this example that we're looking at now. And then the higher order function, it takes these two parameters instead of both being integer, as in the last example. The first one is evolve state, and the second one is the game. So for each event that I have stored in my event store, this function will be called. And then I just, here I do this when thing, switch kind of thing, and I'm forced to handle all the cases. That is nice. So yeah, if the game is created, then I initialize this state here that I call the evolve state, and I set the I set the state from the event, or the values is what I was searching for. The values from the events, I set that in the model. That is very important. And then it just continues. Then when the game is started, I update the state of my evolved state. This is my game state. So now I'm currently started. And yeah, it goes on like this. And then afterwards, I have my state. So I can, work, start working. Okay, so now that I have my evolved state here, then I switch over my commands, or with when, and see if the game is created. And I haven't. Remember, this is like evolve state or null, because it return if I have no events at all in my event store, as is the case when you create a new game, right? So if I have a state already, I just throw game cannot be created more than once, because then I know something's wrong. Otherwise, I just return a sequence of game created. There's not much more here. So it's a little bit more interesting, maybe here in play hand. So here I've done something called accumulated changes, and I call an internal function here, private method, with the command again, and then some accumulated changes. And what is this? Well, this is just a glorified tuple. This is just something that I use internally to collect all the new events, and I will show you soon how it's used. So it takes the state as it is right now, and then it collects new events. Essentially a glorified tuple. I could have just created extension functions on tuple, on pair as they call it in Kotlin, if I wanted to. But then I have some functions here that can help me. So this is the function that is of most interest, and it may look a little bit complex. Maybe it is as well. But yeah, so you can evolve this accumulated changes thing. So you can add. You can imagine that you add new events as we go along. We will see the example soon. But we add new events, and what happens when we add one or more events? We call this very same evolve method that we saw before. But instead of passing null, we don't want to start from scratch. We know what the current state is here, right? So we pass that as the first parameter. So we start from this model, and then we evolve with the events that we want to add, which means that we can always be up to date inside our model. And then we also add these events to this list here, because this is what we will return later. Yeah, and then there's just some fancy stuff. So if you have this accumulated changes thing, you can use this plus operator overloading just to make things, I don't know. Yes, so I can use plus. And you can add a new event if you like. Or we will look at this thing here as well. So you can take a high order function. So this can also take a function that takes and it will supply itself as an instance, and then take it expects another instance back. So another function can mess around with this. Yeah, but we'll see soon, hopefully. Oh yeah, and maybe if you saw before, we have the initialize from, but that's just so I don't have to call the constructor for some reason. I don't know. Maybe I thought this was nicer. I don't remember actually. Yeah, but now let's zoom in here to the play function. Okay, so here what happens is that now I know that I want to play the game, right? I've already identified that before, so I know that this is what I want to do. So then I check which state I'm in, and now there are a lot of talk about state here, but this is the game state. Which state is the game currently in? So if I'm in created here, this is the most advanced thing, I think. Then I take this accumulated changes that I have. It was just initialized, so it contains no events, and then just a state that says that it's created. But then I do plus here. I call this plus function, and this plus function is actually this. So it will just call this evolve thing here with this event game started. So I have these changes. I want to append this thing here, and then I will get the new accumulated changes back. So this is immutable. But then it gets a bit more complicated, arguably. But so now I call this function instead. This function here that takes that takes a higher order function, and then I call this is the Kotlin way of doing a function references. But if we zoom in here, I think it will be more clear if we zoom into the start new round. So start new round is also again just a private helper function to start a new round. But and yeah, it checks some things here, some business rules. But the thing of that might be interesting is that this the function doesn't fit, right? It takes too many parameters. It doesn't fit the function that accumulated changes wants. This is a function that takes accumulated changes and returns accumulated changes. But this function takes a timestamp and then accumulated changes. So it doesn't fit. So then we can use partial function application. So we create a new function from this function that has one argument applied already. So this is what we do here. We do dot partial, and then we just supply this timestamp. So this will return a new function that takes accumulated changes and return accumulated changes again. And now all of a sudden it fits, and everything is nice. And partial, this is not something that's built into Kotlin, but it's really easy to write. It may, I don't know, it may look a bit abstract, but you can write this in one line if you want to. So it's quite easy. And then it just continues like this. You start a new round and then you play the game. And there are more rules and stuff in play. But this is essentially what I've done in this example to implement this model. And it's not, I do throw exceptions. So it's not really pure, not total functions, but I think it's functional enough. And again, you don't need to, if you think this is complicated or, and you know, it might be, I don't know, but you can do whatever you like in here. The important thing is this. Okay, so, but if you create your domain implementation like this, and then how can we test this? I know some frameworks, for example, you need a custom framework to test your model, but not if you just have functions. I mean, we all know how to test functions, right? It's very easy. I mean, this is just one example. This is vanilla JUnit 5, so nothing magic whatsoever. And you just, I mean, you know how to construct a list or sequence of events, right? And you know how to call a function. And you probably know how to check if this list has some elements in it. And I think you come a long way to test your logic. Then you probably want to have some integration tests as well. Yeah, so what other approaches do we have? So we can use a pure domain model. And if you just want to have a purity, and that's really easy, actually. The only thing you need to do is to implement something called something like a result. So instead of throwing your exception, you change the type signature here to be a result of a sequence of events instead. And then you can just, instead of throwing, you can return result with error. Or you return success. So that's actually very easy. I don't know, this probably doesn't give you very much if you just do like this. You can just throw exceptions maybe. Yeah, what you should probably, sooner than later, you probably want to do something else here, like mapping and maybe flat mapping and stuff. So then probably you should maybe consider bringing in a library like Arrow or something that has this either type built in, but with a lot of other stuff. And also, I just want to mention this. I think this is not really good as well, just throwing some throwable here. I think this is actually quite important. It has nothing to do with event sourcing, but it's just like, I think that we should, raise our errors. Does it work now? Okay, good. Okay, so we can refactor this with also small changes. We can have two functions instead. So one function that takes some state and one function that takes the event. And then you can use the same model for both event sourcing purposes and non-event sourcing purposes, which can be nice. There's another way that you can do, and this is how I typically start off, at least, that you don't have any commands explicitly defined in a data structure, because you don't necessarily need to have that, because it's just functions, right? So instead, you can just write a function that takes your events, your previous events, the ones you stored, and then instead of having a command, you just take the things that you put in the command, you take them as parameters to the function. So then you get this instead. Then you don't have to switch and stuff inside your function, and you don't need to define any commands explicitly. And I like this approach. And then I just want to mention this. This is really cool stuff, but this is the next level. This is something called deciders, and this is it's a guy called, and I don't know how to pronounce his name. It's Jeremy Chesing or something like that. He's done some research and dug into category theory and how you can relate that to event-sourced models, and this has been implemented in different languages. He's an F# guy, but there is let's see what he's called. Ivar Duglaik works on Axon, but he has made a side project called the F model that implements these ideas in Kotlin. And this is really cool. I mean, the things that I've showed before, it's kind of ad hoc. You just had a function, then you can implement things however you like. This brings more structure, and it's actually really cool. You get these, both event sourcing and non-event sourcing in the same model. You get composability by categorical constructs, and this is really cool. I know we had this category theory course or book that we read together and studied, but I remember I talked to one of the guys later on, and I presented this talk for a couple of people, and he said that it was worth reading that book when he found out about this project, because then everything makes sense, that you can actually use this category theory things for real. So that's pretty interesting. So if you're interested in taking all of this to the next level, you should check out this library. And that was actually the end of part 1. So thanks a lot. And next part, we will talk about how we can now store these events, and we will check or look at Occurrent, which is this open source library that I've created. And it's awesome. Sorry?
You take questions?
Yeah, of course.
So my initial thought was that so you don't store the projection.
You can store the projection, yes.
Okay, so I've implemented this way before I had any idea that this was a thing. And I stored the projection.
Yeah, sure.
As the pre-optimization devil in me.
Yeah.
I assumed that it was wasteful to recompute the state every time.
Yeah.
Because I assume that you can have a state that is expensive to compute.
Yeah, sure.
And you don't want to do that every time.
Sure.
Right?
Yeah.
So it's not a rule per se to not store the projection.
No.
It basically turns into a cache.
Yeah, exactly.
The problem is that then you have a state, and then you have events that is supposed to describe the state, so how do you know that it's actually true?
Yeah, that's a problem. Or the accuracy, if you're using event sourcing, then the source of truth is your events.
Yeah, that's true.
So if your projection says something else, then you have a bug in your projection. But that can happen. But there are some tricks that you can use. And as well, you don't have to use event sourcing. You can use many ideas from event sourcing in your model without actually storing your events. So you can have this model that returns. Sometimes I do like this. I return like a tuple or pair of the events and some state, and I store the state and maybe publish as the event somewhere. And that's fine as well. But then you need to keep in mind that the events should actually reflect the state changes, and that can be tricky. But there are some tricks. So if you in your function, if you derive again, if you use your events and derive the state that you return from the events, then you have the correlation between them, and the risk of bugs is lower, I think, if that makes sense.
One more question. The
Yeah.
events that you return from your domain model,
Yeah.
that is only new events.
Yes. Yes,
So they
that's
are
important.
appended to the
Yes.
current list of events. In the
Yes. Yes. Yeah, that's a good question. Yeah. Yeah.
I'm a bit fuzzy on like the size of the list or events.
Yeah.
So like now we have the game.
Mm.
Let's say I can't be in two games once.
So you can.
I can't be in two games once. So let's say
Yeah.
it's
Okay.
more like an
Yeah.
online
Yeah. Yeah. Yeah.
paper scissors.
Yeah.
And I have to keep track of all users
Yeah.
playing all games.
Yeah.
But like I'm wondering
Yeah.
how you think about the model and like
Yeah. That's yeah. That is okay. Number of okay. I don't know. Maybe there are two questions, or maybe maybe there could be one like if was one question if you have lots of events, or no?
I'm more thinking about the expected size of this list of events.
Yeah.
And like how you model this. If you have something like I have to keep track of, you can't be in two games at once.
Yeah.
Repeat that question?
Yeah, I can try, but I think I understand. Like if you have a constraint that you're only allowed to play in one game at a time, yeah, and that's tricky. And I mean, in event sourcing, that is tricky, and there are ways to get around that. You can get around it later. I mean, we can detect after the fact that you are now in two games, and then you do a compensating action. You kick the person out of one of the games. That's something that is, I think, quite typically done as well. But yeah, I think that you can do things that I will show you in the next part. It all depends on your scale and data size and so on. But I think there are other things you can do to simplify things. If you want to be pragmatic, if you want to go all in, then it's hard. If you don't have a legal like obligation to not create let a player be in two games at the same time, then you typically just do a compensating thing after the fact. Otherwise, but these things can be really hard. That is an excellent question, I think.
So query the read side and ask, am I already in a game or not? You know, query the read side to check if I'm already in a game and I can't do a new game. So you need query the read side to know what you can instead.
Yeah, but then the read side can be asynchronous, right? So it's not up to date. So you're not guaranteed. So if you have a legal thing, then that might not work. So yeah, but a good question. Yeah.
Taking on this conversation.
Yeah.
I mean, I feel like that happens often as soon as you start scaling where you have the read side that you trust to validate events,
Mm.
and then the restart is outdated because you have a lot of nodes acting and inputting events at the same time. It's not always possible to do like compensating action. Is that something that there's a way to remedy?
Yeah.
The answer is read from the event threads.
Yeah.
It's always easy to search for those threads.
Yeah. No, it's not. I don't think it's always easy to search for them. But maybe there's a library that makes it a bit easier. Maybe. We'll see in the next part. Yeah. Okay. Okay, thanks. Does it work? Okay. Okay, so then we're going to continue with part 2, where we're going to look how we... Like this? Okay. Is it better? Okay, good. We're going to look at this Occurrent library and how we can actually store these events that we just returned from our model. And because, yeah, nothing that you've seen so far has had anything to do with Occurrent, this library that I've created. But now we're going to look at more infrastructure things. And yeah, I just want to mention this is open source. The build is passing. It's Apache 2. You're very welcome to join. It's awesome. It's an awesome community of one. So why did I create this? Yeah, I wanted to focus on these building blocks that I presented earlier. You know, event sourcing, functions, and subscriptions. Partly because, you know, how can I make it easier to get event sourcing into an existing project maybe? And also, of course, I wanted to, you know, experiment myself and see if I, you know, can write something myself that is usable without, you know, having to, I don't know, spend years writing something. I also wanted to, this was very important, I wanted you to be able to design this domain model in any way you like, as long as you take events and return new events. I wanted it to be a library and not a framework, again, so that you can hook it into existing things and not, yeah, and Occurrent is a lot of different components that you piece together. You don't need to use everything. You just need to use the parts that you want to use. Yeah, I want you to be in control as much as possible, and I want it to be interoperable and portable, which is why I've chosen to base it on something called CloudEvents that we will talk about soon. And I also want it to be pragmatic. So, for example, if you're using Spring Boot, it would be nice to be able to hook in to Spring or some other framework and use or leverage the existing frameworks instead of having to learn something new. And yeah, I wanted to build this on a commodity database, something that I know pretty well personally. So I started off with MongoDB because this is what we are using in many of our services at work. So then maybe I could sneak this in at work as well. Yeah. So CloudEvents. What are CloudEvents? CloudEvents is a CNCF specification, Cloud Native Computing Foundation, the same foundation that has Kubernetes and a gazillion other projects. It's a specification for describing events in a common way, and it's typically used in distributed systems to allow services to be loosely coupled. And CloudEvents, it is a specification, and it's already supported by many cloud providers. So I know that we are using Google Cloud, but I think Microsoft also have support for CloudEvents, and in Azure, and I assume that Amazon also have it. I don't know. But for example, in Google Cloud, they have some special cloud functions that supports CloudEvents natively. You can also have some listeners to Google Cloud PubSub that understands cloud functions also natively. Which is quite cool, and this is why I chose CloudEvents, because it is a standard. So instead of me, you know, coming up with some format myself, I can just use a standard. And yeah, this is what it looks like, more or less. So yeah, if we start off here, we have the spec version, and this is the version of the specification. Here it says 1.0. And that's good. It means that this is mature. And now I'm going to talk a little about what this means in the context of event sourcing, or what I've decided to typically put in the cloud event from the event sourcing perspective. If you want to read up on what the specification says, you can read it up on cloudevents.io. Because the definitions here are broader than what I will say here. But from an event sourcing perspective, the type, you can imagine this is like game started. This is the type of the event. Typically, I use it for that. So the source, if you use to event sourcing, there's something called typically called a category in event sourcing. And take for example, if like in this game, rock paper scissors, maybe you have players of the game. That could be one category, and then you have the actual game. That could be another category. And in the cloud event specification, this needs to be a URN, which is why I have defined it like this, a URN. And then we have the subject. So typically, I use the subject is the name of the entity. And subject is actually optional, and Occurrent actually adds two. By default, when you write an event like this to the database, it adds two additional so-called extension attributes to the cloud event. And so it adds something called stream ID and stream version, so that we know which stream to put the event. So yeah, maybe I should clarify that, because you don't, when you append events to an event store, you don't just have typically one list of all your events. You compartmentalize them in different streams. So typically, if we have this game, you typically will store every events for a particular game instance will be stored in one stream. So then the stream ID will typically be the ID of the game. But you can also put the ID of the game here. You don't have to do that, but this can be useful because you can have different entities can be represented in the same stream. Sometimes that's valid, and to differentiate between them, if they are in the same stream, you can use the subject. So yeah, and then you have the ID. That's the ID, the unique ID of the event. Note that this, according to the cloud event specification, the ID doesn't have to be globally unique. So this can be many times, you have this, your database generates on 1, 2, 3, and 1, 2, 3 is not globally unique, apparently. But the source and ID, those two together, needs to be globally unique, according to the cloud event specification. Yeah, and then we have the time. This is RFC 3339. And then some, how you store your data, because you can store that whatever you like. JSON, and then you have, for example, and then data. This is your stuff. So this is essentially an envelope that you just have around your data that you have in your event. So in Occurrent, there are some different abstraction levels. So we're gonna start off here with this level that works with cloud events, and then we're gonna explore some other layers here. But this is the lowest level where we're working with cloud events. So let's first look at the event store. So what I've implemented a couple of different implementations in Occurrent. One, for MongoDB, and in memory, I have started working a little bit with support for Event Store DB. Some other person started working with Postgres, but I think he's bailed. And then I think this is really cool. I really want to find some time to try to implement it with Spanner. That would be just awesome. Spanner is this Google database that almost beats the CAP theorem. It's impossible, but they come really close using some tricks like atomic clocks and stuff. But that would be awesome. Then you can scale a lot. But I have 3 different implementations. If you don't want to use Spring, you can use this vanilla Java driver thing. I have a Spring blocking implementation and a reactive implementation as well that uses Project Reactor from Spring. And then I have an in-memory implementation for testing. And this is just an example how you create the Spring MongoDB event store. You create some MongoDB things, the client, define some transaction manager. This is some Spring stuff. Then you have some configuration where you want to place your events, in which collection, as we call it in MongoDB, like the equivalent of a table. And then you just new up the event store. And then you can use it. So you use it like this. You define a cloud event, and this uses the standard cloud event SDK. So this is not something that I've created. This is the SDK that already exists. And you build your cloud event, and then you write this is the ID of the stream, typically then the ID of your game, and then you write the event to the event store. And then you read events as well. You probably want to read. You specify the stream ID. That should probably be the same ID as there, but maybe it didn't fit. I don't know, or I just forgot. But notice here, this is an important thing actually. It doesn't only return. I mean, you could imagine here that we just return a stream, like a Java stream, if you're familiar with Java, or a sequence. But no, we return something called event stream, and that is important because this contains some more information, some metadata. What is the current version of the stream right now? So that if you have, so we can implement optimistic concurrency control, etc. So that is important, but it's still lazy. And now comes the cool thing, I think, because if you remember, the cloud event, and I will go back again. Let's see how it looks like in the database when it's actually stored. You see, it's very similar, right? And I think this is really cool because this is a cloud event as well. So even in the database, it is the very same structure. And I think that is really cool, actually. And I leverage this. We will see that later. The only thing that is magic here is I add this stream ID and stream version. So here you can see for each new event that we pass in, we will get the version of the event. Yes, but it's still a cloud event. So and I really like this. I think because in another way, if I maybe use another framework, then I always so how is this stored? I don't know. Maybe if that is not a good fit for me, I want to get out of it. Since this is a cloud event, maybe there are some tools already that can get things out of MongoDB and put it somewhere else. That would be cool. So I think this is great. Did you have a question?
The stream version in this case.
Yeah.
Would that be an incremental number?
Yes, the stream version.
To kind of see where you are when you want to apply new events.
Yeah, exactly. Yeah, the question was if this stream version thing is incremental, and yes, it is per stream. I have not implemented global ordering. That's really hard. That's something Event Store DB has global ordering of events. But that's a different discussion if you need that or not. But so that's actually the event store. That's kind of nice, right? But then you need to subscribe to new events that comes into this event store. So we have subscriptions as well in Occurrent, and in Occurrent we have something called subscription models. So you create an instance of a subscription model, and then you use that to subscribe to an event store. And I have a few different subscription models, and you can compose subscription models together or wrap them in each other, so delegate them and to build richer functionality. And I will show you an example soon. And a pretty cool thing, I think, is that you can use a reactive subscription model if you have a blocking event store, or vice versa, and you can have multiple different subscription models. So if you when to use a reactive is if, for example, if you want to work with streams of data, because the blocking implementation is callback based, and that's fine if you're dealing with individual events. But if you have multiple events, maybe you want to do real-time aggregation or something, then it's better to use the reactive API. But you can choose whatever you like. It's distributed, so you can run your subscriptions on a different node than where you run your event store. So that's also pretty nice. And in the simplest case, this is the blocking subscription model, by the way. Simplest case is just that you subscribe, you have an ID of your subscription, and then you have a callback. And the callback here is a higher order function that takes a cloud event and just returns a unit or what's called void in Java. So this is prints every event. Now you subscribe to every event in the system if you do like this. You can also pass in when you want to start. So by default, it's now. but you can start, you know, in what's it called, in an earlier time, if you like. What is this? I skipped it. Yeah, and then you can also specify filters, and this is enabled, right? Because we know even in the database that we have CloudEvents. So then we can use this little API or DSL kind of thing here to construct filters. Like, so we're not interested in all events. We're only interested in events that has type, and this type here comes from the CloudEvent specification. That's type game ended. Then we only get game ended events. And yeah, these are like composable. So subject, we talked about that before. So you can filter with subject and type, and then we get that. Then this is maybe a little bit more advanced, and I don't know. Yeah. So okay. So what you need to do as well, if you restart your application, then you don't want your subscription to you want to restart your subscription from the time or from the position that it was before, right? You don't want to restart it again when you start up and you start from the current position. You want to make sure that you don't miss any events, and for that you need to store your position as well, the position of the subscription. And yeah, there is some things you can do if you want to write this yourself. You can do that or implement these interfaces. So here is one to show you. I think, yeah, this is how you can do it. If you're just using a subscription, then after you have done some stuff with the cloud event, you probably want to save the subscription. But of course, you don't have to do this yourself, because there are built-in these subscription models that do this for you. That takes this, what's it called, some storage thing, and it creates this durable. You create that with a durable subscription model. So this is what I mean when you wrap something that is not durable, you pass that into this durable subscription model, and then it just uses the other subscription model and then adds durability on top of it. And then you can compose this. Oh, I didn't have an example of that. But you can compose this with other subscription models. For example, I've implemented this competing consumer subscription model. So if you have distributed consumers on different nodes, and you only want you don't want every consumer to get all of your events, then you can use a competing consumer subscription model. Yeah, so that's essentially it for subscriptions. There are these reactive and blocking. You can pick whatever you like. There are 2 different implementations right now for this, where you store your position of your events, and you can configure how often you want to store, or this is also called checkpointing, but you can control how often you want to do this and so on. Yeah, exactly, that's what it says here. And there are some other subscription models that can be nice as well. So what other features can we does Occurrent have here currently? So yeah, here are some things that we will look at. There are queries and operations and blah 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 blah. So first, let's look at queries. You can see that there's a little scream thing here. That means that this is a bit contested on whether you should actually do this or not. Personally, I think this is fine, but it depends on your scale. If you have like a low to moderate amounts of events, and your database have the ability to create indexes, and you create indexes for your queries, then I think that this is fine. This makes it much simpler in many cases than having to create subscriptions and then build your materialized things. You can just query the event store for the events, and this works great. I mean, MongoDB. Yeah, I know MongoDB has a reputation, but you can query. You can query quite a large amount of data. I mean, that's it's built for that as well. So I don't know, why not? And it uses the very same this DSL API thing that we saw before with filters. It's the very same thing that you use here for, but instead of creating filters, now you just use it for querying the event store instead. So in this example, we query the database for all events the last 2 hours for this particular subject. And then we sort it by descending order. And then what we get back here, it doesn't say, but here we will get a Java stream with events back. And here I just want to emphasize, because this is something that event sourcing people think it's important that you need to have an all stream. You need to be able to get all events lazily from the event store. Otherwise, it's not a real event store. So here I prove to you guys that this works as well. Okay, so now it gets even more screamier. 2 screams. I said before, right? You should never delete an event. But yeah, here you can delete an event. Oh no. And that is typically something that you don't want to do many times. But there are situations where you might want to do it. For example, you know this was just a bug. I mean, we should never have this here. We're in the I don't know some experimental phase. We can just get rid of the events and start over. I don't know, but you see 2 screams, so you should be a little bit cautious. But there are legitimate use cases as well. We were talking about it during the break, like there's something called closing the books, or if you want to take some snapshots. Maybe you have so many events that your database. I mean, if you're not using Spanner, then probably you never need to think about this. Google needs to think about it. But in all other databases, probably you need to think about something like this. Like if you have a gazillion of events, then your database doesn't work optimally. Then you probably want to discard old events and create something called a snapshot, or even better, closing the books that are snapshot that are more business oriented. So essentially a projection. So maybe every month or every day, maybe there is a business in your business. You close a store every day, for example. So that's a good time to create a projection, get rid of your old events, or not. When I say get rid, you can get rid of them, but maybe you transfer them to some cold storage somewhere to still have the events, but live you have a projection and then new events for that day, something like that. And then you want to delete things. So, for example, if you want to close the books, then you have read 19 events, then you delete this stream, and you delete all events with version less than 19, for example. So I think that this is legitimate and something that you can use. Okay, 3 screams now. No, because you can even update an event. Oh no, immutable pieces of data. You should never do this. So yeah. If this hurts your eyes, that's probably good. But yeah, I don't know. Maybe there are some use cases for this, like GDPR, if you want to remove data. And there are other strategies for this that you can use. You can encrypt your events, store the encryption key somewhere else, and just delete the encryption key. Then you don't need to delete. But yeah, I mean, this is one option to update your event and remove personal data. Why not? It works. But yeah, 3 screams. So be careful. Yeah, and then we have, I think we mentioned this as well. Maybe it was a question. Yeah, because, yeah, if we don't use, first of all, we can use, we have this database that we can use for queries, and we can create indexes. So we can create arbitrary indexes as long as it fits in memory and all the rest. So we can actually create unique constraints. So, for example, whoever asked this question before with like maybe we have this constraint that is cross-boundary, cross-aggregate constraint. Like a person can only play in one game at a time, or only one person can have the same email address or something like that. That is a hard thing to do in event sourcing. You can compensate in things after the fact, but or you can use a unique constraint in the database. And I've done this. I mean, I don't have a gazillion amount of data, but if you don't have a gazillion amount of data, then I think this is much easier to do. So that is a trade-off. If you want to be pragmatic, then I think you can do that. And what does the other thing mean? Enforce constraint from read models transactionally. What does this mean? Oh, maybe it means the thing, yeah, someone of you, I think, told that as well before. Like, yeah, reading from the event model before, reading from some read model before you write to the event store. That's also a way to solve this, email. No person can have multiple emails and stuff like that. But here, since we're using MongoDB, then you can use transactions. So you can, if you like, you can start a higher level thing. So you can transactionally read from your read model and write in the same transaction. And you get this, atomically. And you can do things like that which you typically cannot do with the normal event stores. And again, all the normal things apply. If you have a, want to global planet scale, then yeah, probably not the best idea. But yeah, it can work as well. And I have no idea what this means. Any takers? I don't remember, unfortunately. Oh yeah, I have a sheet here. It's okay. Now I get it. Okay, so maybe you have some read models that you prefer to be updated transactionally. Like just take this case that can be a bit tricky. Like if you play the game, but you have a synchronous API, so you want the result to be returned or something. Then you can do a lot of fancy stuff and wait and stuff and things like that. But one way would be to maybe update this read model transactionally with your events. You update both the read model and the events at the same time. This is also something that maybe there should be some scary things here as well. But it works if you don't have a gazillion number of events, I think. At least that's my experience. Okay, so let's look a bit about integration testing. So maybe, I don't know, but I've created some other open source libraries as well, mainly focused on testing. So yeah, I want things to be testable. And that has not always been the best experience with some other databases and frameworks that I've worked with. So when it comes to integration testing, these now we're back to subscription things here. So the subscription models also have life cycle support. So what you can do is that you can start and stop individual subscriptions. So if you have multiple subscriptions that subscribes to your event store, maybe the same event, when you write integration tests, you want to shut them off and just have one, the subscription that you're interested in. That's the only one you want to have live. So here you can easily shut them, stop them, and resume them and start them. And that can be very nice. Okay, so typically, or I don't know, you can go in here and do whatever you want and build higher levels of abstractions if you want. But if we now go to level 2, I will just show you some other things that that I've written. And these things here are some higher level abstractions that uses the things here. Just some small wrappers around the lower level. So first thing that we're going to look at is this application service thing here. We have talked about that a lot, but we haven't really looked at how it looks like. And yeah, it's essentially an interface that takes 2 parameters. It takes the ID of the stream, the game ID, and then it takes a function, a higher order function. This is Kotlin Code again, but a higher order function that expects a sequence or a list. It works with lists as well, by the way. But if you want to be lazy, then you take a sequence of your current events that you have in your event store. This is what will be fed here, and then you return your new events. And this is how you can use it. Okay, now we're back. Now we have this handle function again that we saw earlier. We have your events, and now we have this command, and we have some configuration where we instantiate our event store and some other things. Something called Cloud Event Converter. We will talk about that briefly soon. It's I can mention it now. It's a little thing that knows how to convert from your domain events to cloud events. So this is the thing you use to map between these 2 worlds. So back and forth. So the application service, it takes an event store and one of these Cloud Event Converter instances. And then in your REST API or HTTP API or whatever, somehow you get the things that you need, the game ID, who creates the game, max number of rounds. You create a command, blah, blah, blah. Now you have the command. Now you call the application service for this particular ID. You get your current events. And all you do is to call your handle function. And this will return events, so it will comply with the function that we saw on the previous slide. And it will store the new events for you. And make sure also that it will use this optimistic concurrency control and stuff like that and recovers. But you can easily write this yourself. I will actually show you kind of how it looks like. And here you can arguably make it a little bit nicer, because again you can use partial functions. So you can just use handle and create a partial function and pass in the command, and you get it back. And this partial thing here, this is also, it's included in this application service library. What else? Oh, yeah. So what if you don't have a command? It's the same thing. If your functions look like this, you don't have a command. It's the very same thing. You instantiate your stuff. But of course, instead of instantiating your command, you just call the create game function in this case. It's the same thing. And again, I hope, yeah, you can create a partial function like this. Pretty cool. Yeah. Oh, but this is cool. Now you need to look closely. Down here. Oh, maybe I have. Now I will click this before. Yeah. You see this? You can compose commands. So this is why I, if you remember, I separated between game started and what did I actually separate? I don't remember. Yeah, game create game, and start game. And the reason for that is because maybe, I mean, in your domain model, those are expressed maybe differently, but maybe in REST API, I don't want to first create a game and then start. I just want to play, and then the game is started. And you can do that without changing your domain model. Instead, you compose your functions using this compose command. And compose commands is really easy to write. It's just a fold left again. You fold over the returned thing and pass that into the argument to the next. So no magic, no framework stuff. It's just function composition. And everything here now will be stored atomically. So both of these, I don't have to do anything. Just write the fold left. I mean, this is awesome. Right? I know I can see the water in your eyes. It's beautiful. Yeah. Yeah. Oh, yes. You might be scared. Maybe this application service, maybe it's scary and complex. No, it's just like, I don't know, 5 lines of code, more or less. No, but the actual implementation has a couple of more lines, but not many more. Essentially, you just read from the event store. You transform your stuff from CloudEvents into domain events. You pass that to your higher order function that you passed in, and then you save it back using the version that you get from the event stream. This is really important, otherwise you can run into trouble. So it's actually very easy. And if you don't like this, and this is the purpose as well. I mean, maybe you want to do some tweaks here, and then you can just, I mean, either wrap the existing one or just copy the code and write stuff yourself. I have no idea what the time is, but yeah. So let's look a little bit about this cloud converter, because I want to say some things about this, because it's an interface, blah blah blah. You create to and from, or convert to and from CloudEvents, your domain events. And I have some implementations already, so you don't have to write it yourself, although I recommend that if you want to use it in production, I do recommend that you write it yourself or do some tweaks with this one, the Jackson thing here, probably. And the reason for that is, here's an example of a custom one. So here I have all my events, and what do I do here? Okay, yeah, so I map the event, each event, the data. You create a hash map of the stuff that I want to save in the data field in the cloud event. And then I create a cloud event here, and this will then be saved in the data store. But what's important here, why can't we just use Jackson like natively? Or we can, but first of all, Jackson, you know, it doesn't always work very well if you're using Kotlin and data class and immutable stuff. Then you may want to have annotations and stuff like that, and that's fine. That's a trade-off that you can do. But what if you do it like this? If you have this mapping layer, then you can decide for yourself. It's not forced to have these annotations. But either way, what Jackson needs is it needs, you know, in order to be able to convert it back from your cloud event to your event type, it needs, since it uses reflection and stuff, it needs your fully qualified name. And you should not use, probably, you can decide that as well, but you probably shouldn't use a fully qualified name. That is actually the default with many of these. Like if you're using Spring Data or something, they will default to fully qualified name. I think that's horrible. But yeah, it's easy to get started with. But then if you move your events to a different package or something, then things might start breaking. But the cool thing here, even if you have a fully qualified name here as your event type, you can still you can fix that later. You will get some exception probably, but you still have the data, and you can create map. Oh shit, I forgot. So you map between the old and the new package name, for example. So you can always fix that, and I think this is nice that you have this separation between your cloud events and your domain events. Yeah, blah blah blah. And this is the other way around. Yeah. Now we're moving to some completely different thing. This is just some higher level construct. It's called a subscription DSL. This is also a library. So if you want to subscribe not to cloud events but to your domain events, you can do like this. This is a Kotlin, the Kotlin version. But here you subscribe, and then you specify your domain event type here instead, and you will subscribe to all your domain events of this type. And you can subscribe to multiple and so on. So this is more probably more nice if you don't want to work with cloud events. And again, the same thing with queries. If you don't want to return queries, there is a little library for this as well. And this is the Kotlin functions. So these are Java libraries, but what I show here are Kotlin extensions. So yeah, you can query for different things, and it will be more in your domain language, so to speak. And then we have just a little bit about views. I'm not sure what I will show you, but we'll see soon. Okay. So here I want to show how we can create persistent views that we were talking about that before. This is a very simple example, but just to show you that it doesn't need to be hard. Like what you do is that you create a subscription, and then in this case, and this is maybe a little bit too trivial, but here it just counts the number of ended games. So imagine that you have some database, Redis or something. It's essentially just inc some value. Now, if you want to use this in production, you should probably be more careful, because of course you always have this, like you can get events more than once. This is true here as well. So it's at least once delivery. So you should probably not just inc, because if this is important. If it's not important, then of course. But for more complicated views, you probably want to have a contract here as well. So you take your event and your current snapshot, or your current view, and then you can fold again and return a new view. This is just a simple example. Or you can use derived views, right? So you can use this event store thing and just query, and from. Now this is also very simple. You can just count. Now it's consistent. It's not the other thing there was eventually consistent. This is consistent because you're querying the event store. Remember to create an index, otherwise it won't work well. It will work well the first day, but then it won't. And again here, I think this is real nice. I mean, you remember for left, you can query for events with a particular query thing here, and then you just fold into your data structure of choice. I like that. Oh, I even have this. Wow, yeah, this is what I actually said before. That you take an event and your current view, you return a new view. That's how you can do that. And now we're almost finished. I only have 5 slides left. This is level 3. This is just because I think I have I actually have pretty good documentation, I think. But it can be a little hard if you want to bootstrap fast, we're using Spring Boot. So I wanted to write something that you can bootstrap it fast, so you don't need to read all the documentation and assemble all your 30 different small pieces. You can do that, or you can start by this, or using this. The only thing you need to do is to depend on this, and it will wire up all the Spring beans, and it will create an almost production-ready set of stuff. But you should really check out. You should, as I said before, I want to avoid magic, but now we're on level 3, right? So it becomes more magic. But you should check. You should look at the class that declares all the beans, so that you have an idea of what it's actually doing. But it's saying it's almost production ready. The thing that it's not possible for me to do is this cloud event converter. So what you can do is to tell, there is this Jackson Cloud Event Converter, and that's actually pretty smart. You can just tell it how to map your type. That's the only thing you need to do. Then it is actually production ready. Or you can write your own custom one. But you should be aware that you should change, because it defaults to fully qualified name. So you should change that. Otherwise, it should actually be good to go. Oh yeah, here that is as well. And now it's the last thing. This is really work in progress. This is what I'm thinking about right now. The only thing I know is that it will not look like this. But I just want to mention this because I think this is pretty cool. So what I want to do is like a module thing, so that you can see your application. You will still use your core functions, but you will like declare your entire application like this and delegate to different functions all over the place. But you have this, so you know you don't have to click around. And I mean, you have your application here. And what I want to do is to be able to compose modules. So if you want to have like a well-structured monolith, you can maybe, I don't know, use this, and maybe I can enforce some rules automatically with arc unit or something, so that you cannot call other modules from without integrating with integration events or something. So yeah, this is what I've been starting thinking about now, and yeah, I have some interesting ideas, and also more things. Snapshotting, I have no real support for that. I think it's quite easy to do actually yourself, but this is something that I will add some things for that. And then one thing we haven't talked about are sagas or something called process managers. This is an advanced thing, and many times I don't think that you need it. But there are simpler options you should look into. Again, the guy who created event modeling, he has some good thoughts there as well, that you should represent your process managers as something, as to-do lists instead. That makes things more simple. Or just subscriptions. Integration events, maybe I'll do something about that. And then scheduling deadlines, this is really cool. I want to do more stuff there, so you can schedule something in the future easily. Like I want this command to be sent in 3 days or something. Or trigger like time passed events, like the day has passed, something like that. And just trigger that every day. And I have some ideas on how to do that, I think. Yeah. And you should look at this website. When you come home, do your first commit. Let's make this awesome together. Yeah. Thanks.
Thank you very much.
Thank you.
Johan. I think we should stop the live feed and just continue here with some Q&A. So if you up for it.
Yeah, definitely.
All right. So, yeah, thank you, guys from the internet. See you.